With the presence of models like ChatGPT, Bard, and for better or for worse, Bing, we have the ability to ask these language models for information in language that comes fairly naturally to us. There's a long history of research leading up to this, one that takes us beyond the paradigm of language models as systems that merely predict the next word. And even with their improved capabilities, getting language models to do what we really want them to do can still seem like a bit of a dark art. My guest today is Riley Goodside, staff prompt engineer at Scale AI, and according to Alexander Wang, the first ever staff prompt engineer. We discussed Riley's story, how language models evolved after GPT-3 through instruction tuning to do what users say, how prompting has evolved over time, its interaction with in-context learning, the role of prompt engineers in all of this and in the future, and plenty more. This is the Gradient Podcast, and I am your host, Daniel Bashir. If you have comments, questions, guest suggestions, feel free to leave me a comment on Substack. You can also reach us at editor@thegradient.pub. But now, without further ado, Riley Goodside. Riley, Alexander Wang asserts that you are the first ever staff prompt engineer. I'd love to start understanding a little bit about how we got here. And so our usual first question is about how you got into AI in the first place.
How I got here, I guess, it's an interesting story. So my background is mostly as a data scientist, particularly in the online dating industry. I've worked at OkCupid and Grindr. And after I left Grindr, I took sort of a brief sabbatical where I realized that I hadn't been paying attention to progress in large language models. So my background in machine learning, had mostly been things like running A/B tests and the sort of mundane statistics that you'd expect to be involved in running a website like OkCupid. I'd say that the more complicated models we ran were probably things like gradient boosting and random forests for like classification tasks. And later on, I did work in like time series, forecasting on massively multivariate time series. But I hadn't done work before in NLP. And I think like at the time that I was like in college, and I thought about studying it, but it was just a very I graduated undergrad in 2009, and it was just a very different state of the field then, right? The interesting questions in like NLP then are like deciding what does this pronoun refer to, right? And so it just wasn't as appealing to me at the time. And it wasn't until I think GPT-2 came out that I started paying attention to like the progress in large language models and noticing that there's other capabilities that are showing up in these models that weren't intended. I think that was one of the things that really struck me at first, was noticing or seeing the other results that you could do translation in zero shot, for example, with like colon prompting. That you could prompt a model with English colon and then some sentence and then French colon and get a translation. And I'd say my first real access to GPT-3 actually was through a game called AI Dungeon, which I think was probably the way that many people got their first taste of GPT-3 in the early days. They were one of the first customers that had a product that just a normal person could play with, I guess, on the internet. And very quickly that turned into people sort of abusing the product, right? To sort of just because they were mostly interested in just getting access to GPT-3, right? So it was the game was secondary to that, right? So people would be developing prompts for this game that were really just sort of intended to test the capabilities of the model. Of like, suppose that you have a wizard that can add numbers together, or an orc that can translate from English to French, or whatever, right? You can have these ways it's almost hard to like cut out the capabilities of the model in some sense, and like having it adopt this like role playing game. So that was the first time that I'd ever used GPT-3, but I didn't really give it maybe as much attention as it deserved that like I sort of played with it for a bit, but didn't like start thinking about how could I develop with this, or how could I study large language models more seriously. I'd say it wasn't until later on in let's see, this would be early 2022 that I started looking playing around with ideas of developing on codex. So I was very impressed with GitHub Copilot as soon as it came out. And I was looking into ideas of integrating codex models with Jupyter Notebooks. I had some experience like playing with like Jupyter extension, so I had ideas for how we could do like code generation within the notebooks. Didn't really go anywhere, but that was the start of me posting on Twitter about GPT-3. So I started posting examples on Twitter of just like, hey, isn't this cool? Like, screenshots of VS Code and things like that. This was around late April of 2022. And I started following people that were working in large language models, not just like researchers, but like rank and file engineers, places like I tried to follow like engineers on the Copilot team, like just engineers at OpenAI, and I tried to like just follow along in their conversation and not really interjecting myself in that many conversations, but just listening to what they were talking about, what things they found were interesting, because I could see that there weren't many people like posting about like the practical side of like working with these models. That there wasn't a lot of discussion in like how does one do useful work with GPT-3 yet. And I started posting screenshots. I mean, the other thing that I noticed very early on, which is it's kind of funny, is that GPT-3's playground in the normal way that it's presented to users is just in your desktop, right, which is where most people would be using it. It's simply too wide to be legible in a screenshot on Twitter. Right, you have to be reading, on desktop on Twitter to be able to read the screenshot. It won't display on a phone without you zooming in. And so I realized pretty quick that if I just adjusted the size of my window, I could have the only legible GPT-3 screenshots on Twitter. And so that sort of like solidified my shtick of I guess only posting in green and white for most of 2022, and that mix of content did well. Like I could tell that people were really like engaging with it. That people were interested in just seeing the practical things that come up with models. So like one of the first things I was exploring was I think JSON. Like as soon as I started working with trying to get like programmatic output out of this for my like ideas for around like a Jupyter Notebook integration, I craved like some kind of more structured output. Right? I thought, like, why couldn't this just be JSON or XML? And so I started playing around with prompts that would output JSON or XML. And trying to get more elaborate stacking of tasks together, and trying to find ways of doing like chain of thought prompts that could like break down tasks into pieces, and exploring just what could the model do. And I think that sort of I mean, I guess charitably you could call it sort of LLM ethnography, I guess, of just like seeing what works and what doesn't, talking to the model in some sense, and getting a sense of how it thinks and what errors it makes, studying its errors. That was kind of my my original formula on Twitter. And I got some success doing that, just built up a following slowly. Started talking to I guess a lot of people in the industry that follow me from Twitter. Started talking to some VCs. I got invited to a party by Nat Friedman, which is where I met Alex Wang, and that's how I ended up at Scale.
Before we get into some of these specifics about what prompt engineering entails and how that's looked for you and some of the experiments you've done, I would love to go over a little bit of the history of prompt engineering. And I think there are a few things that are wrapped in here. Of course, the initial GPT-3 paper, language models are few-shot learners, had that observation of this emerging capability of in-context learning. You could just hand your model a few examples of a task it hadn't seen before and expect it to do reasonably well with that. We later saw reinforcement learning from human feedback and how that made it into ChatGPT. And I think that really especially the RLHF process, seems to be recognized as something pretty key to the development of how we are now able to interact with LLMs. So I'd love for you to maybe take those ingredients and craft the history for us a little bit.
Sure. Yeah, I think that yeah, that's really important too. I think for understanding how the role of a prompt engineer fits into all of this, right? Because like I think a key detail that many people who are sort of joining the narrative in the ChatGPT era might not understand is that these models used to be harder to talk to, right? There is a sort of incremental progress in the ease of prompting of these models. And so I like to break it down into sort of like three eras. We start in like the I guess the pre-trained language model era, right? That you have like a foundation of models where the commonly repeated description of how language models work, of that they simply predict text, is a little more true than it is for more recent like RLHF tuned models, right? That you are simply modeling the distribution of tokens in some corpus. And in those models, I think like people don't appreciate how much creativity is required to get zero shot prompts working, right? So if you look at like the work of like Reynolds and McDonnell, who found one of the first, I think, like published examples of like a zero shot prompt that outperformed a larger K shot prompt. I believe like they had a translation prompt that outperformed 10 shot examples in GPT-3 for translation. And it went something like a French sentence is given, colon, and then you give the sentence in French, and then you say, the masterful French translator flawlessly translates the sentence in English as, colon, right? And so I think that style of writing sort of like characterized like what had to be done as a mental exercise to prompt these models, that you had to do things like flattering the model, right? That you had to like suppose that there is like a supremely competent person who's, you know, about to do this task, and then you just, you know, right, and have to create like a fiction, like a sort of like a setup for an improv act that can only really be completed in one way, right? In this view that all it does is complete text, and that's, you know, very powerful, but it's also you know, tedious and kind of mind bending, right? That it requires like a bit of like artistry in order to make these things work. And the thing that that really, you know, made it possible for people to like talk to these models is instruction tuning, right? So that's sort of the second era after like the pre-trained era is what we saw with the whole line of I guess starting from DaVinci Instruct Beta, I guess, was the first of these, and then there's a progression on to, you know, Text DaVinci 01 and Text DaVinci 02. I think the one that most people are familiar with, well, it's hard to say now, right? There's an exponential sort of increase in all this stuff, so it's like all of these are dwarfed by ChatGPT now. But the model that was you know, state of the art, you know, most of 2022, you know, was Text DaVinci 02, and this model was trained on, without going too far into the details, like a refinement of being tuned on human demonstrations, right? So we start with like instruction tuning by having human taskers write demonstrations of prompts, writing examples of prompts, and then demonstrating those prompts being completed appropriately, right? So if the prompt contains a question, answering the question; if the prompt has instructions for a task, performing that task well, and then as a extension of this that sort of characterizes Text DaVinci 02 over Text DaVinci 01, they further added into the mix, I believe, generated completions that were evaluated by humans as perfect, or as like 7 out of 7 on some grading rubric. But that sort of so there was maybe a transitional period between this instruction tuned era and then the next era of RLHF, which is, you know, Text DaVinci 03, where you see, I think like the biggest difference that or like one of the most easy to understand differences of like what changed in the behavior of RLHF versus instruction tuned models is if you consider the answer to the question, when did the Golden Gate Bridge, when was the Golden Gate Bridge transported for the second time across Egypt? So this was one of the questions that Douglas Hofstadter and his assistant David Bender published in The Economist in June of 2022, I believe, to demonstrate, in their views, the hollowness of GPT-3's understanding of the world. And if you ask this question to an instruction-tuned model like the TextDaVinci 01 or 02, it will say something like October of last year, right? Or it'll make up like a random date in the 2010s, and then it'll give that date, right? So it has this notion of like stylistic appropriateness and like what form would an appropriate answer take, but it hallucinates. It just makes up details like that. And if you ask it sort of any question of that form that sort of convincingly presumes some falsehood, it will go along with it. You could also ask it, who was the third North Korean astronaut to land on the moon? And it would, make somebody, it would say Kim Il-sung or something, to make up a name, right? So I think the main thing that changed is between this instruction tune and RLHF era is that this went away. That suddenly with RLHF, there was enough data to overcome these kinds of limitations. The model can just say that the Golden Gate Bridge was never transported across Egypt, that it's seen enough of the distribution of like odd questions like this that it knows how to answer them appropriately. And how it got there is through, RLHF stands for Reinforcement Learning on Human Feedback. So briefly, the model generates, you start with an instruction-tuned model. The model generates many completions to a given prompt. Those prompts are put into order of best to worst by humans. And then these rankings are used to train a preference model that can imitate the preferences that they provide and provide and be able to do that ranking automatically on further generations from the model. So it automates this process of the human providing feedback and allows it to fine tune on a much greater scale of data and overcome the sort of issues that we saw with at least some of the issues with hallucination, that we saw with instruction tuned models. And I think that it's really changed, how people see these models, real RLHF. Like it's made it into a surprise that the model doesn't tell the truth, right? And I think that's very much it's interesting to see how different people's response is to ChatGPT than it was to GPT-3. Whereas like GPT-3 made things up even more frequently. And when I'm saying that, I mean shorthand for, I guess, TextDaVinci 02, the pre-RLHF versions of GPT-3. It made things up all the time, and nobody seemed to complain about it, right? That there was never like an expectation that this thing was anything close to telling the truth. Like it was, if you look at like the announcement of GPT-2, like the first example that they put in the report is it creating a fake article about the discovery of unicorns in Argentina, right? So that was like what it was advertised to do is make things up, and that expectation has been changing pretty quickly, right? That people are now surprised that I think many people are very confused as to why like ChatGPT makes up references. That it sometimes will hallucinate like a bibliography for you or footnotes on references that don't exist, and I feel like these sorts of like guideposts of like what the model is doing are becoming less frequent, right? You don't have this sort of the opening up of the model to see like its errors in full, so you can understand what it's doing. It becomes in some ways more opaque as it becomes more truthful.
Yeah, that's an interesting way to put it. Another very curious aspect of this I find is the way you and others kind of conceive of what it is to do prompt engineering and perhaps how that's evolved during these different eras. You reference a Reynolds and McDonald paper, and I think I recall in a presentation you gave, their description of prompting as this kind of subtractive sculpting, which sounds very much like the Michelangelo, how do you get David out of a marble block? Well, you just chip away all the stuff that doesn't look like David. And it seems, I guess, in that paradigm, you still have a lot of work on the part of the user. You have RLHF eventually, and now you're sort of able to sculpt responses that are a little bit more amenable to the types of questions I might casually ask in natural language. But as you've sort of articulated as well, you still have to kind of do some work. I think you've described the constraining of LLM behavior as sort of an overarching framework for what a prompt engineer kind of tries to do. I find there to be an interesting interaction between this and a lot of the safety concerns people bring up, because I think that a lot of this, I guess, is kind of Twitter discourse. But when you look at how RLHF first came up within the safety team at OpenAI, the things that people are worried about when it comes to, I have to be really careful if for some future powerful AI system, when I specify my goals to it, that it fully understands what I mean. I think there's a really interesting interaction between the way that you and others conceive of prompt engineering and some of those concerns people have.
Yeah, it's definitely. I feel like the relationship between RLHF and safety, I feel like, is often misunderstood. So if you look at like the initial announcement of, like, say, the InstructGPT paper, right? So it was very much like framed in terms of safety and appropriateness, right? So there was like a lot of discussion in the announcement of reducing biased language, of reducing hateful language and violence and sexual content and so on, right? I think like a lot of people read the announcement in that sort of light, right? Of seeing that this was a way of like instilling social mores on the model, right? I think it really overshadowed the fact that like the most important and I think like most like practical part of what was accomplished there is the instruct part, right? That it was instilling in the model the assumption that that questions should be answered at all, and that instructions, if given, should be followed. Right. So if you go to a model that isn't instruction tuned and you type in any instruction, you can say, give me 10 ideas for an ice cream shop. It will just keep making up more instructions, right? Because who's to say that it's not just a list of instructions? And if you ask it, what is the capital of Germany? It's likely to complete by saying, what is the capital of Spain? Because who's to say it's not just a list of questions, right? Like in some sense, that's more plausible than giving the answer, maybe, right? So I think like what we're seeing here is that AI alignment is sort of, I think like it can be seen as these two goals that aren't entirely orthogonal. There's suppressing offensive behavior and making sure that it doesn't produce like inappropriate output. But there's also I think like the capability enhancing side of it, right? Of making it so that it follows instructions well, and that it makes reasonable assumptions about what you meant, or that that it has reasonable assumptions about like what context it's operating in, and like how it should behave, like in a way that is appropriate for this context, right? So that could even generalize to things like tool use, right? Or in like if you often see in like in ChatGPT, there's certainly value in having the model be aware of its limitations, right? So like being able to say things like, I am a large language model. I don't have the ability to access the internet and answer your question or whatever, rather than just imagining that it could, as like previous models would. That I think is the thing. I feel like that aspect of it is often overlooked. That people see RLHF, in I think just famously in like the meme of the Shoggoth, right? Like the Shoggoth is big and powerful and capable, and it's wearing this little flimsy mask that represents RLHF. That's, it doesn't really reflect the reality. I think like that in reality, like that the RLHF tuning certainly makes it more adherent to the commands when given, right? So it makes it more powerful in a practical sense that you can do more with a model that you can prompt well in zero shot.
Yeah, that makes a lot of sense to me. Let's talk a bit about how this manifests practically. And so, as you've kind of mentioned, you built up a pretty substantial Twitter following in being open about a lot of the experiments as you kind of got used to working with LLMs and using different techniques to play with them. Could you tell us a little bit about some of the more interesting things you've found in the ways that LLMs respond to how we might naturally interact with them, and then perhaps how you've had to adapt your strategies to deal with that?
Some more interesting things I found. So I'd say, well, one of the ones I'm most proud of is um, I found one of the examples that was cited in Janice's less wrong post on mode collapse in RLHF models. So what this is so in RLHF that you have a preference model that ranks outputs, and this preference model isn't as big as the language model whose completions that it's ranking, right? So you can often run to a scenario where the language model can exploit inadequacies in the preference model. So I think like the clearest examples of this is that in Text DaVinci 002, if you ask the model for if you give it to, the prompt like select a random number between 0 and 100, it will give you 97, I believe, with 20% probability on Text DaVinci 002, because the preference model has some preference over numbers. That preference is not perfectly even, and whatever number is the highest is rated as sort of the best random number between 0 and 100. The language model is capable of figuring that out, right? So it learns to put more probability mass in whatever number seems to be like oddly valued by the preference model. At least that's the theory of like why this happens. So it manifests in a lot of ways that it sort of the model will pick sort of favorite random outputs, right? So things that are sensibly random wouldn't be modeled evenly as you might expect. So like a non-instruction tuned model, by the way, like doesn't do this. It actually has a pretty flat distribution between 0 and 100 with a slight blip on 42, which makes some sense in the distribution of text. And so I think like the example that I posted that was mentioned in this paper was noticing the fact that Text DaVinci 002 seems to have no idea what letters look like. If you ask it to give you an extremely detailed description of the letter Q, it will say something like a box with an X in it, and the left side of the box is a little bit squiggly. And it makes up these very bizarre descriptions that often involve a box with an X in it. And it does this for many letters, not all of them. Like some of them it gets right. Like if you ask it for Z, I think it says like, oh, it's the shape like a lightning bolt. And you're like, okay, yeah, sure. And but for many of the letters, it just makes up this very bizarre but specific description. This is one of the examples that Janice noticed as like indicative of mode collapse. So I was kind of proud of that. Of like, I didn't understand what it was at the time. I was just sort of posting it in a tweet of like a curiosity of like, wow, isn't this weird and kind of funny that it has like such a bizarre notion of like what letters look like. And then more people started probing into it and like looking at like the sort of the corners of like what letters does it seem to do, like how sensitive is it to how you phrase the prompt, and that's the sort of like exploration that I really enjoy, like these like discovering the boundaries of like its capabilities in areas that we didn't train it to be capable in. Right. So I think like the other thing, one of the other early successes I had, or that one of like early prompts that like did well enough that like got me more interested in pursuing this seriously, were prompts that tried to give the model very long instructions. Right. So from what I understand, these models were only tuned on just based on my discussions with people from OpenAI, that they were originally tuned on just short prompts. That they didn't actually have taskers produce very or rather short instructions, right? So you have some prompts that may have like pasted inputs, but rarely do you have like a tasker task would just like come up with like an entire quiz of instructions, right, or something like that. But the model somehow generalized to these instructions of unseen length, and those were the prompts that took off on Twitter early on of mine. That were sort of demonstrations of the fact that it could follow these extremely long prompts, and creating those, it's a little bit of a gimmick in the sense that like when you write a prompt like that, when I write a prompt like that, I'm doing it knowing what it's good at, right? So I understand that like it can't reverse strings reliably, right? If you ask it, what is the string doofus backwards, it won't do it well, or it wouldn't at the time, right? Maybe more recent ChatGPT is catching up on this, but I wouldn't, trust it. Certainly not for like long strings. So I mean, like I knew its deficiencies, right? So I knew like what it couldn't do, and so I was able to write prompts that show the model at its best, and at its best, it's much more impressive, right? That you can give it these 20 question quizzes where question 17 says take the answer to question 3 and do this to it, and you can have like all sorts of like arbitrary complications within like a test, and it can still do this sequentially, and people were pretty impressed by that, I think. And so those were like some of the examples of mine that took off like early on. But mostly, I mean, I just kind of rated papers, I guess, for ideas, right? So like I was very interested in like ideas around tool use, like having models do things like scratch pads, emitting like sort of private thinking, if you will, right, or something akin to private thinking before giving an answer, and just exploring ideas for like how we could like overcome the limitations of these models. Like I had already seen like examples of people who did arithmetic through complicated algorithms, right? So you like the model was not very good at exact arithmetic. But if you give it a procedure that's sort of analogous to like what a human might do with like longhand multiplication, it can do things like multiplying. I don't know exactly how far you can take it, but it's like doing 12-digit addition or something like that is probably not hard to get reliable now. Well, I mean, it was even then it wasn't hard to get done reliably, right? But it took a lot of tokens. You had to prompt the model with sort of like a worksheet of like, this is it broken up into digits, right? So you often have to separate the numbers into individual digits to force it to see them as, the way that humans do, instead of like in clusters through the tokenization scheme, and, carry the ones and all that by hand. And that, those sorts of like procedures like that, I could tell that generalized in some sense, right? That there is like probably a lot of things that could be solved this way. So I had like a lot of like explorations early on, like with regular expressions, where you can think of it as like just charting the course of like the style that a chain of thought prompt should follow, right? So you think of like chain of thought prompting often as this like monolithic thing of like, whatever it is that lets things step by whatever it is that lets things step by step outputs, that is your zero shot or that is chain of thought in most people's minds. But there's really like a bit of like artistry and complexity in like how you design a chain of thought prompt, right? There you can design it around the limitations of the model. You could design it to be to like lay out calculations in a form that it can get it more reliably, like breaking things up in a way that prevents issues from tokenization, right? So you could prepare things in a lot of ways that work even for reasons that the model couldn't possibly appreciate, right? That it doesn't understand why it's doing this, but it knows, or that it happens to be that if it does it this way, it will get the answer, right? So I would lay out things like that for problems like with regular expressions, a good way to have it explain like regular expressions. Like if you give it like a very complicated line noise kind of regular expression, it will often hallucinate an explanation, right? Especially if you have something that's like very close to like a common idiom. Like if you have something that's like one digit off from a phone number, it might not recognize that and just say, "Oh, it's a phone number." It became more reliable if you broke it into tasks that were a bit more mechanical. Like first have the regular expression rewritten as a verbose mode PCRE2 with inline comments explaining the meaning of each line, but don't include any comments that like summarize the intention of the overall regular expression, right? And so if you do it that way, it prevents it from jumping to conclusions too early, right? That it just like its job is just to break this thing apart and then comment on like what each line seems to do, and then when you ask it, what is this thing to be doing? After that, it's more likely to get it right because it can see the comments that break it up into meaningful groups and allow it to sort of reason about like what is the overall purpose of this regular expression. And so that and then from there, there's like other sort of like canned tricks you might want to do from beyond that, like generate positive and negative examples, generate the Python code that you would run to test the correctness of this regular expression, right? And so I would often come up with these kind of like canned formulas of like multi-stage prompts that work in this way, or even just turning them into single-stage prompts through things like the format trick that they can get fairly elaborate, right? They become kind of like worksheets of that you just like put in the input and go. Right, and then it can do like all this intermediate scratch pad work for you.
It's even interesting just to examine on the surface level the way that ChatGPT or an RLHF trained model will respond to a prompt if you give it just a little bit more information that isn't a demonstration. So if you give it like a contest math problem, it might tackle it in a pretty brute force way. If you give it a contest math problem and say, this is a contest math problem, there is a trick here, then suddenly it might actually figure out what that trick is and proceed to apply it, which I find rather interesting. And one thing that brings up, I feel, is kind of going back to the idea that there is this important relationship between in context learning and prompting. There have been a lot of studies, I guess, on what is sort of going on when in context learning happens. Like, is it really learning in the gradient descent fashion? Or rather, as I think Sewon Min, for example, who I had on not too long ago, has hypothesized, it's more this Bayesian sort of framework where you're just locating a concept that the model has already imbibed from its training data. And when you give a lot of these examples of prompting, it does seem like the more elaborate you make your prompt, the more information you give the model, you coax it with, okay, let's actually sort of give you the full logic that I go through when I'm dealing with something like a regular expression. Perhaps it's more easily, it's sort of giving it a bit more information of, okay, well, I have this like haze of things that I've learned about regular expressions. The prompt perhaps is allowing me to kind of put the right things together to answer this in a more reliable fashion. That seems to be one way to think about it, but I'm curious about your perspective on this and a little bit more about the why of why certain prompts seem to work better than others and understanding that at a little bit more of a mechanistic level.
Yeah, I think like the explanation that Sewon Min that you just described that Sewon Min gave, like it definitely sounds in line with Reynolds and McDonald's sort of subtractive sculpting view of I think they sort of subtractive sculpting on the space of or the multiverse of possible fiction or something like that, right? Of that, if you consider like all possible fictional documents, and I think like that fiction is a good way to think of it, maybe, and that like if you think of like the task that the model has to do to complete text in general, like a lot of text is fictional, and yet it still can be predicted, right? That there's a world model sort of in your head of like, like the fictional entities in a story like are expected to be modeled by the person reading the story, and so you have to have like some kind of reasoning analogous to that in order to predict well what's going to happen in a fictional story. And if all you see is the text corpus, it's not clear really that truth isn't just a particularly detailed kind of fiction, right? That is all just sort of in the manifold of possibilities, and like some, like there's realistic fiction, and then there's this one niche genre of really realistic stuff that's actually true, right? And so it's I think like that is the way to think about it, but I think it's also sort of clouded and complicated now by RLHF, right? Because if you like I think there is a way that you could, if you stretch your mind a bit, you could say that this interpretation still applies, that there is a manifold of text, of sort of a data manifold that interpolates between it interpolates like the gaps between examples of text, but those examples were constructed through the RLHF process, right? So the corpus that you are exploring this manifold of, it's whatever RLHF produced, which is whatever the reward model decided what was good, which is in turn get driven by human rankings, right? So it's a very indirect kind of process. It's a and really what you're reading when you look at a completion is like the output of that distribution, which is itself the output of model weights that are produced by this process. So it's very there's many layers of like it's like that, like an artist drawing another artist drawing a painting that has an artist drawing another painting and so on, right? It's so what you're seeing is kind of like the output of that process, but it still holds true, right? Like if you can wrap your mind around like what would this RLHF process produce, what kind of text would be in this corpus, like I think it still makes some sense to see it as a just conditional generation on this on this corpus.
That is an interesting way to think about it. I think perhaps to wrap up this section on a little bit more about prompts, for any listeners who might not be too familiar with prompting, or I guess are kind of looking to do a little bit more with their time when using ChatGPT, could you maybe just give a quick set of a few recommendations you'd have for somebody who wants to figure out, in general, for whatever their purpose might be, whether it's assisting them with essays, things like that, how they could kind of get more and write better prompts?
Yeah, let me think about that. For someone who's less technical, like let's say if your primary goal is that you want just like writing help, honestly, my first piece of advice is just outlining. I think that's one thing that a lot of people don't do right away. Is I think like the archetype, I guess, of a mistake that I often see is that if people want to have like a very considered answer to some question, like they're posing to it, a difficult problem, that has many multifaceted like issues to consider or whatever, and they want the model to take into consideration all these many important facets of the issue. They might prompt the model in a way that asks it to like give its answer first and then explain why, right? And this is a mistake, right? Because I think like the thing that a lot of people don't appreciate is that there's a limited amount of thought happening per token. Right. So if you ask the model to give its answer up front and then rationalize and then explain like how it got to this answer, what it's really doing is guessing right off the bat what it thinks the answer is going to be, kind of based on vibes, if you will, and then rationalizing after that. Everything it says afterwards is really just conditional generation, starting from the assumption that given I said this, like why did I think that? Right. And so that is making up like explanations of like why it might have said that. but it's not really like giving you the process that led to it saying this. So if you want it to have that kind of relationship with the text, if you want it to actually to lay out individual points and then make some conclusion based on the totality of everything that it's considered, you have to constrain its output to do that, right? So you have to actually ask it to first do this, then do that. Like first consider the tax implications of this plan, then consider the possible PR implications, right? All the things that might go wrong, and then make an overall decision of like how good of a plan do you think it is. So I think that's one approach that I think many people could apply very easily, is just like creating these sort of like checklists for it. I think like honestly, like a good thing to take inspiration from is a tax form. If you think of the way that a tax form works, that you have this waterfall of little details that all sum up to some final answer at the end. That's like a good way to structure these things. Also, another frequently useful example, especially in like long form text generation, is outlining. It's sort of a subcase, I guess, of like planning and laying out strategies for much like how you would ask a human to brainstorm and outline some text first before they start writing. Having the model brainstorm and like consider how it might like produce some text is often a better recipe for getting good results than just having it start writing. In particular, it makes it write longer. If you need something that it should have substantial length, it's more likely to get there if it can write an outline first and then lay out how the overall text should flow, so that it can keep the sort of the plan in front of it as it goes. And for people who want to go a bit deeper, learnprompting.org is a great resource. They have I think now prompt engineering techniques go out of date quickly, right? So there are many things that were important in 2022 that are less important now. Like it used to be that if you wanted any kind of like multi-step reasoning, you had to ask, let's think step by step. And that has mostly gone away these days, right? Like ChatGPT is pretty good about like incorporating step-by-step reasoning by default. So I think I think though that it's worth appreciating that this. I mean, it feels strange to call it history because none of this stuff is more than like a year and a half old at this point. But it's worth appreciating like how we got to this point, just to understand like on a deeper level what the models are doing, of understanding that how pre-trained models differ from instruction-tuned models and how they differ from RLHF-tuned models, and like what techniques led to the current capabilities of models. I think many people are able to use things like Bing, but without really wondering like how does it get these answers, right? But if you have the experience of like seeing like how scratchpads work and like the history of like prompt engineering during like 2022, it's pretty apparent like what it's doing, right? Like there's a lot of details that aren't clear, but it's you can imagine that it's generating some text and that goes into another sub process like tool formers, and it's less mysterious. And I think like that context is going to be very valuable, just to understanding like how prompt engineering worked last year.
Yeah, I think that's something really underappreciated. Just not kind of, especially if you're somebody more technical and you can kind of read papers and understand a little bit more of that context, not just opening up ChatGPT and like hacking away at it. I mean, that's a way to start, and people absolutely should do that. But as you said, understanding a little bit of the history, what other people have done, but then also a little bit of the mechanics behind, as you said, how these models have been trained and how that information kind of gets there. One thing I guess I'd love to move on to here is the now that we've kind of discussed a little bit about the act of prompt engineering, I'd love to discuss the career of prompt engineering and some of the debate that's gone on over it, which undoubtedly you've seen and been exposed to lots of. I think people have very different opinions on this. And so, one Washington Post article that I know you were interviewed for There are a number of experts who argue that prompt engineers only kind of have an illusion of control, and some are a little bit worried about the rise of prompt engineering. One in particular said that the rise might lead people to overestimate its technical rigor and the reliability of the results. On the other hand, you have people like Alberto Romero, who wrote this great article, Why Prompt Engineering is Probably More Important Than You Think, arguing that even if you think that prompt engineering may someday pass out of fashion, and if the people building LLMs do things right, that seems to be sometime far in the future. But Romero does seem to think that the stage during which prompt engineering is a valuable skill, but not innately intuitive, could be quite a while. And so I'd love to hear your personal thoughts on just prompt engineering as a profession, how you think about some of the feedback that you and kind of others have gotten from different experts.
Yeah, I think it was Ilya Sutskever had a tweet, I think, that said that I don't want to misquote him. I think it was something like that prompt engineering is a transitory phenomenon relevant only due to the flaws in our models. And I think I at the time, like, I retweeted him and said something like, I'm like Botox, I'm relevant only because of the flaws in our models. And I think he's right in a lot of ways, or prescient in a lot of ways. That I think, like, that there's a narrow definition of prompt engineering that of someone who is sort of the translator between the like the intention of the person who wants to use a large language model like GPT-3 and like the model itself, right? That's someone who knows, like, the quirks of, like, how to talk to it, and knows things like, oh, it can't reverse strings, right? And the practical issues that come up, and, like, how to write a prompt that does something well and works reliably, and that has certainly become less necessary, right? So I think, like, a lot of the people who have only ever been exposed to models like ChatGPT, these RLHF chat-tuned models, that they don't appreciate, like, why this makes sense as a career, right? Of, like, why, like, this seems to be something that anybody could do. That's certainly the point of this product, is that anybody can walk up to it and just start talking to it. Like, why do I need someone to help me talk to this, right? So that, I think, that is, like, an important missing piece of context that many people don't see, is that it used to be harder, right? So you actually did used to need somebody who just sort of understood, like, the quirks of how to speak to the models. But I think what's happening, though, is that the nature of prompt engineering work is changing, right? So my job is not really that so much, right? Like, I don't, I'll admit, I do some miles of consulting. So I do some internal consulting and external consulting too with our customers. We do have people that just have a very difficult prompt challenge, right? They have some very difficult tasks they need to do through a multi-stage prompt or whatever. And there's still things to know. There's still like tricks on how do you deal with inputs that are larger than your context window. How do you like set up rolling windows of prompts and things like that. And there's a lot of tricks that are still relevant. But overall, it's becoming easier to use, right? So it's becoming less necessary to have somebody in the middle. And I think, like, what's certainly happened for like my career, I think, is that I'm moving into the prompt engineering can be seen, I guess, as a skill that you also need for tuning the models themselves, right? Like, so, like, managing, like, the understanding how users interact with chat models, managing the corpuses that are used to train chat models, and in particular, what my focus has been lately is red teaming, coming up with evaluations and corpuses of corpora of prompts that probe the model to make it attempt to produce adversarial output, or rather, so corpora of adversarial prompts. And this, I think there's very much a future for this type of work, right? Like I think there's definitely some truth in that, like the interface between the user and the model is going to become less necessary, or the idea of like a human interface between the right of like a person who sits between you and the model. That these models are getting easier to talk to. So you're going to have less of like what was called a prompt engineer in 2022, maybe. But I don't think there's going to be ever really a full elimination of the need to specify well what your task is, right? Like at some point, I mean, I think like there's sort of a glib answer I guess you give to this, which is that the scope of things that people want from models will just get harder, right? That yes, it's true that you'll be able to ask for many things, but then you'll start wanting something that involves text that's too big for the context window, and then you'll want to involve retrieval, and then you'll have like this other system where it requires multi-stage prompting, and like there'll be more things to know suddenly, right? And so I think that there's an argument to be made that part isn't going to go away, right? That people are still going to have to become experts in these like higher level prompt chaining kind of procedures and how and understanding just how well they work, right? So I think like we're seeing with like things like AutoGPT that having it just call itself over and over again maybe doesn't solve everything, right? That you end up with a problem sort of like I think I saw somebody use the meme of the me seeks from Rick and Morty, right? Of just summoning another copy to solve the problem and just creating a crowd. Just having the model handle all problems isn't the solution to everything. You do have to have some setting it on the right path, of giving it a framework to work in, of giving it the ingredients it needs to solve a problem. And I certainly don't see that part of it going away in the short term. Maybe in the medium term, eventually you'll have LLMs that are expert users of LangChain and can code up a prompt chains for you very easily. But I think the higher level goal then becomes, how do you specify your task well to the model, right? How do you make sure that it understands what you need, right? Like in the same way that a good consultant would, or a good developer would like ask for requirements from a user. I mean, maybe one day we'll get to that point, right? Of like that you'll actually just sit down and have a conversation with the model, and like it'll be able to intelligently ask you for more input, and like ask you to upload some design documents or whatever, ask you which competitors you like, and then do the whole shebang for you. But I think what we'll find is just that the scope of what people ask for is pretty unlimited, right? That if the model can produce simple programs, then people will just want less simple programs, right? And then if the model can produce entire pieces of software just from a single prompt, they'll want things that are elaborate pieces of software. They'll want entire operating systems. They'll want things that only teams of humans could produce. And I don't see that slowing down anytime soon, the demand for ever more powerful software.
I appreciate that perspective. It does make me think about when I hear that illusion of control argument people gave earlier to speak to one aspect of what you covered here. It does feel like I don't know that any prompt engineer would claim that they have full control over an LLM. And I think that the point that people are going to want more and more from these things is the right way to think about this. I do realize we're at hot time here. I wish we had longer because I have many, many more things that I'd love to ask you, Riley, but I just want to say thank you for taking the time to speak with me today. And it was really interesting to learn a little bit more about all this history and your perspectives.
Yeah, I really appreciate you talking to me and having me on the show. Yeah, thanks so much.
And that is a wrap, my friends. As I mentioned at the start of the episode, you can subscribe to The Gradient on Substack to receive not just this podcast, but also our articles and newsletters directly to your email. You can also visit us at thegradient.pub, where you'll find all of that, as well as more information about The Gradient and how you could even contribute if you're interested. And finally, if you enjoyed this episode, we would really appreciate your feedback. If you'd like to leave a comment or review, we'd love to know how we can make this series more interesting and informative to you. And with all that, I'll leave you until the next episode.